everyone. Welcome to our subject, Electronics and Robotics. We are now in second quarter, week 7, and our topic is logic gates. So before we proceed, I hope you are fine and safe while watching these video lessons because of this pandemic. So I hope you are in a safe condition. My name is Dick Edward Sagala, Teacher 1 from Baler National High School. Okay. So, have you ever wondered how a computer can do something like play chess, um, spell check a document, or balance a checkbook? Computers are not really intelligent. They just do exactly things they are told to do and do it rapidly. So after watching this video lesson, you will be able to define what is logic gates, discuss the truth table, and you will be able to construct your own AND gate. One of the basic logic gates using the electronic kits that I will provide to your parents. Okay, let us discuss what are logic gates. So, logic gates perform basic logical function. When we say logical functions, they are used to test whether a situation is true or false. And depending on the result of that test, you can then elect to do one thing or another. So that is logic gates. They perform basic logical functions and the basic building blocks of any digital system. So as you can see in these pictures, these are examples of logic gates embedded in the microprocessors, microcontrollers, and other system applications. And logic gates is an electronic circuit having one or more than one input and only one output. So let us explain on the next slide. Logic gates is capable of processing only one bit or binary digit at a time, 1 or 0. In digital electronics, 1 or 0 represents the absence or presence of voltage, respectively. When you see 0, it means absence, and 1, it means presence of voltage, which is always equal to 5 volts. In some programming of digital electronics, they use other terms other than 0 and 1. But if you see these words off, no, open, and low, it also means zero voltage. Okay? And on, yes, close, and high means there is presence of voltage, which is um, always 5 volts. Truth table. Associated with logic gates are the truth tables, which shows the gate output Q for each of the possible combination of the two inputs A and B. So as we said earlier, logic gates have two inputs, more than one or more than one inputs, and only one output. We use symbols A and B for inputs and letter Q for output. And when we say truth table, it is the possible combinations of the two inputs and the corresponding output. So this is the example of truth table. Okay, let us proceed to AND gates. So AND gate is one of the three basic logic gates. These are AND gates, OR gates, and NOT gate. So we will now study what is AND gate. So in AND gates, inputs A and B are connected in series. When both are open, there will be no current in the output Q. So it means that when the input A and B is in open circuit, meaning the switch is not on or not pressed, um, there will be no current in the output. Our output is the lamp. Okay. Now, if you close one of the inputs and leave the other open, still there will be no current in the output Q. So when we press, basically, literally press the switch A and leave the switch B open, still there will be no current in this lamp. Now, if we close both of the inputs, there will be current in the output Q. So there will be a current in the whole system. The current will be able to flow through the circuit diagram, and then the lamp will be turned on. So that is why this gate is called AND gate. This input A and input B should be switched on together. So again, that is why it is called AND gate. They are connected in series connection. Okay, so AND gates are basically depends on type of connection of the two inputs. Okay. Let us now proceed to the actual construction of AND gates. So before that, let us review the circuit diagram of AND gate. So the switch is connected. The two switches or the two inputs are connected in series connections. So we have power source and then connected to switch A, and the switch A is connected to switch B, and the switch B is connected to the lamp, and the lamp is connected back to the power source. So we have jumping wires, the LED and the resistor. This color is resistor, and we have two switches. We are also using USB cord and cell phone charger. Okay, first connect the jumping wires to the USB cord. Please use color red, symbolizing that it is positive line, and color black to the negative line. And then to the red jumping wires, connect the resistor. Okay, connect the resistor. Okay, and then connect the USB cord to our cell phone charger. So the purpose of the resistor is to lessen the actual voltage produced by the charger. So our LED is only capable of using 3 volts, and our charger is producing 5 volts. So the purpose of the resistor is to lessen the voltage. And then connect the switches to the breadboard, switches A and then switches B. Okay, ang paggamit ng switch ay yung magkalapit, yun ang ginagamit natin. So 4 kasi yung leg ng switch, ang ginagamit natin ay yung magkalapit. Okay, remember that. Next is, remember the long leg and short leg of our LED. So long leg is up, our positive line, and short leg is for negative. And then connect to, using red jumper, connect the positive line to the positive leg of the LED, which is the long leg. And then use black jumping wires to connect negative line to our first switch, and then connect other using other black jumping wires, connect the other leg of switch to the other leg of the switch B, and then connect to the switch B to the short leg of the LED. Testing, when we press both, the LED is lighting. Okay, that is end gate. So what we have learned. So we have basically three things that we have learned. First is logic gates uses switches, and the operation of output depend on the kind of circuit connection. Okay? It depends on the kind of circuit connections. Okay? For our previous example, the circuit is connected in series. And then it called AND gates. Number two, AND gates switches are connected in series, and output will be on if and only if inputs A and B are switched on. That is why it is called AND gate. Okay? And number three, truth table shows the different possible combination of inputs and its resulting output. Okay. For the application of our lessons, the working principle of logic gates, to understand the working principle of logic gate, let us consider example of street lighting system. The circuit diagram of street lighting system, which may consist of logic gates, NOT and OR, switch, and light sensor. The operational condition of street light to function is as follows. So, as you can see, logic gates, as we said earlier, it is embedded in some electronics devices. So they are the one who decides how to function. Okay. So you can also think other examples of applications of logic gates. Okay. So let us now remember that computers are not really intelligent. They just do exactly what they are told to do and do it rapidly. Okay. Let us now proceed to our short quiz. For number one, it performs logical function and basic building blocks of any digital system. Letter A, logic gate. Letter B, circuits. Letter C, chips. Okay, the answer is logic gate. Very good. Number two, it shows different gates output for each possible combination of the two inputs. Letter A, logic circuit. Letter B, mathematical equation. Or letter C, truth table. The answer is C, truth table. Very good. Number three, in AND gates, inputs A and B are connected in parallel. True or false? The answer is letter B, false. Number four, in digital electronics, open circuit means letter A, there is 5 volt present, or letter B, there is 0 volt present? The answer is letter B. There is 0 volt present. Very good. And last, number 5, blank are used to test whether a situation is true or false. Depending on the result of that test, you can then elect to do one thing or another. Letter A, logical reasoning. Letter B, logical functions. Or letter C, logic. The answer is letter C, logical functions. Now you are ready to do your mm, performance task. Okay. Our performance task is to construct your own end gate. So using the kits that I have provided and sent through your parents, create your own end gates. Submit a video of your work to my Facebook account, and you will be graded based on the following: submitted on time, 3 points; working or effective, 3 points; and organized, 3 points, for the total of 10 points. So what is our next lesson? Our next lesson is OR gate. So how are the citrus connected, and construct the truth table for OR gate, and we will also discuss what is mathematical equation. So thank you very much for watching my video. See you in our next lesson.